Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student at Rehan School Islamabad Baraku campus. Today I am going to conduct an AI session with Maya. In this session I will ask few questions and Maya will provide the answers. So let's start. Okay Maya, my first question is what is software?
All right, let's get into this. At its simplest, software is the set of instructions that tells the hardware of a computer exactly what to do. If the hardware is the physical body, the screen, or the keyboard, then software is the mind. The invisible layer of logic that transforms a piece of metal and plastic into a tool that can write a novel, calculate orbital trajectories, or let you scroll through photos of puppies. Think of it like a musical score. The instruments, the piano, the violins, the drums, are the hardware. They have the physical capability to make sound, but they don't just start playing a symphony on their own. The software is the sheet music. It's the precise set of notes and directions that tells the musicians how loud to be and what to follow. Without the score, you just have a room full of instruments. Without the software, you just have a very expensive paperweight. Now, software isn't just one thing. It exists in others. At the very bottom, you have the firmware. That's the software that's baked directly into the hardware, like the basic instructions that tell your laptop how to turn on. Then you have the system software, like Windows or Mac OS, which acts as the man everything else. It handles memory, talks to the and makes sure the screen actually shows what it's supposed to. Finally, you have application software. These are the tools we actually interact with: Chrome, Spotify, WhatsApp, or a video editor. These apps don't talk to the hardware directly. They ask the system software to do it for them. When you click save in a document, the application tells the operating system, hey, I need to put this data on the hard drive. And the operating system handles the gritty details of moving those electrons around. What's truly wild is that all of this, every complex app in every operating system is ultimately just a massive collection of yes or no decisions. It's all binary code, zeros and ones, which are essentially just switches being flipped on or off millions of times per second. We've just found a way to stack those billions of tiny switches into languages that humans can write, which then gets translated back down into those zeros and ones for the machine to understand. So software is essentially the bridge between human intention and machine action. It's how we translate a thought, like, I want to send a message to my friend, into a series of electrical pulses that travel across the globe in milliseconds.
Okay Maya, my next question is what is the difference between software and hardware?
This is where we get into the classic divide. The easiest way to grasp the difference is to think about the tangible versus the intangible. Hardware is everything you can actually touch, kick, or drop on your foot. It's the physical matter. Your screen, the motherboard, the battery, the chips, the wiring, that's all hardware. If you can hold it in your hand or see it as a physical object, it's hardware. Hardware is the engine of the operation. It provides the raw power and the physical space for things to happen. Software, on the other hand, is entirely intangible. You can't touch it, you can't smell it. And if you opened up your computer, you wouldn't find a piece of software sitting there like a coin in a pocket. Software is the set of instructions, the logic, and the data. It's the intelligence that tells that hardware how to behave. Using that engine analogy, if the hardware is the car, the steel, the tires, the pistons, then the software is the driver and the GPS. The car has the potential to move, but it needs the driver's input and the map's directions to actually go somewhere useful. Another way to look at it is through the lens of permanence and flexibility. Hardware is relatively rigid. Once the processor is manufactured and etched into silicon, You can't just change its physical layout. To get a faster processor, you usually have to physically swap the old one for a new one. It's a hardware upgrade. Software is the opposite. It's fluid. This is why we have updates. You don't have to buy a new phone every time an app gets a new feature. You just download a new set of instructions that overwrites the old ones. The hardware stays exactly the same, but the software changes how that hardware is used. It's like having the same piano but learning a completely different song. The instrument hasn't changed, but the result is entirely different. They exist in a symbiotic relationship. Neither one is useful without the other. Hardware without software is just a hunk of metal plastic. It's like having a brain with no thoughts or a body with no soul. It's there, but it's dormant. Conversely, software without hardware is just a theoretical idea. It's like a beautiful piece of music that exists only in a composer's head until there's an instrument to play it. It's just a ghost of an idea. So, when you're using your device, you're witnessing a constant high-speed conversation between the two. The software says, I want to show a blue pixel here. And the hardware responds by sending a tiny burst of electricity to a specific point on your screen. Hardware provides the capability, and software provides the purpose. Does that distinction click, or do you want me to dig deeper into how they actually talk to each other?
Okay, my next question is, what are the main type of software?
All right, let's break this down. When we talk about the main types of software, we're really talking about a hierarchy of needs for the computer. At the highest level, you can split everything into two primary buckets: system software and application software. First, let's dive into system software. This is the behind the scenes stuff. If the computer were a city, system software would be the infrastructure, the roads, the power grid, the water pipes. You don't usually interact with it directly, but if it stops working, everything else in the city functions. The biggest player here is the operating system, or OS. Think Windows, Mac OS, Linux, iOS, or Android. The OS is the ultimate manager. It's responsible for resource allocation, meaning it decides which app gets how much of the CPU's attention and how much RAM it can use. It also handles the file system. So when you save a photo, the OS knows exactly which physical sector of your hard drive to tuck that data into. Then you have device drivers. These are specialized pieces of system software that act as translators. Every piece of hardware, your printer, your webcam, your graphics card, speaks speaks its own weird language. The driver tells the OS, "Hey, I'm a Canon printer, and here is how you send me a document." Without drivers, the OS would be like a boss who doesn't speak the same language as their employees. They're both there, but nothing gets done. And then we have utility software. These are the maintenance crew. Think of things like disk defragmenters, antivirus software, or compression tools like WinZip. They aren't running the whole show like the OS, but they keep the system healthy, secure, and efficient. Now, let's move to the second bucket: application software. This is where most of us spend our entire digital lives. These are the programs designed to help the user perform specific tasks. If system software is the infrastructure of the city, application software is the actual businesses, the coffee shops, the libraries, the gyms. Within applications, you have a huge variety. You've got productivity software like Microsoft Word or Google Sheets designed to get work done. You have multimedia software like Photoshop for editing images or VLC for playing videos. Then there's communication software like WhatsApp, Zoom, or Slack, which bridges the gap between people. And of course, you have specialized software. This could be anything from a high-end CAD program for architects to design a skyscraper to the complex software used by NASA to land a rover on Mars. One interesting trend we're seeing now is the shift from local applications to web-based applications. In the past, you'd buy a disk, install a program on your hard drive, and it lived there. Now, so much of our application software lives in the cloud. When you use Google Docs, the heavy lifting isn't happening on your laptop. It's happening on a massive server somewhere else, and your browser is just showing you the results in real time. So, in short, system software creates the environment, and application software uses that environment to actually do something useful for the human sitting at the keyboard. That's the big picture. Do you want to zoom in on one of those? Maybe more on how the OS manages everything, or are you ready for the next question?
Okay, my next question is what is system software?
Let's really peel back the curtain on this one. Since we touched on it briefly before, let's do a total deep dive. System software is the foundational layer of a computer. If you imagine your computer as a theater production, the application software, the apps you use are the actors on stage. They're the ones you see and the ones doing the actual performance. But system software, that's the entire stage crew. It's the lighting technicians, the sound engineers, the people moving the sets, and the director calling the shots from the wings. You never see them, but without them, the actors are just standing in a dark room in total silence. The absolute heart of system software is the operating system, or OS. The OS is essentially the government of your device, manages the economy of your hardware. Your CPU, your RAM, and your hard drive are limited resources, and every app you open wants a piece of them. If two apps tried to use the exact same spot in your memory at the same time, the whole system would crash. The OS prevents that chaos. It acts as the ultimate arbiter, saying, okay, Spotify, you can have this much memory, and Chrome, you can have that much. It handles scheduling, which is the art of switching between tasks so fast that it looks like your computer is doing 100 things at once, even though the processor is actually just jumping back and forth between them at lightning speed. Then you have the BIOS, or UEFI. This is the most basic form of system software, often called firmware. It's the very first thing that wakes up when you hit the power button. Its only job is to do a sanity check on your hardware, making sure the keyboard is connected, the RAM is functioning, and the hard drive is spinning. And then it hands the keys over to the operating system. It's like the alarm clock that wakes up the rest of the house. And we can't forget the device drivers. Think of these as specialized translators. A motherboard doesn't inherently know how to speak to every single printer or graphics card ever made by every company in the world. The driver is a small piece of system software that tells the OS, here is the specific vocabulary this piece of hardware uses. When you install a new GPU, you install a driver so the OS can finally say, oh, okay, now I know how to tell this specific chip to render a 3D image. Finally, you have the utility software. These are the tools that keep the system optimized. Things like disk cleanup tools, antivirus programs, or system monitors. They don't run the show, but they make sure the show runs smoothly by cleaning up digital trash and guarding the gates against intruders. Essentially, system software is all about control and communication. It abstracts the terrifying complexity of electricity and silicon into a language that application software can understand. It turns a chaotic storm of electrons into a stable platform where you can actually get things done. Does that give you the level of detail you're looking for, or should we explore a specific part of the OS, like how it handles files? I'm ready when you are. What's the next question on your list?
Okay, my next question is what is application software?
Let's get into it. If system software is the stage crew and the infrastructure, application software, or apps as we usually call them, are the actual performers. This is the software designed specifically for the user. Well, system software is there to make the computer work. Application software is there to make the computer useful for you. Think of it like a smartphone. The Android or iOS operating system is the system software. It's what allows the phone to boot up, manage the battery, and connect to the Wi-Fi. But you didn't buy a smartphone just to have an operating system. You bought it to use Instagram, to check your email, to play Candy Crush, or to navigate with Google Maps. Those are the applications. Application software is incredibly diverse because it's built to solve specific human problems. You can break it down into a few main categories to see the scale of it. First, you have productivity software. These are the digital versions of the old Office desk. We're talking about word processors like Microsoft Word, spreadsheets like Excel, and presentation tools like PowerPoint. These apps are designed to help you create, organize, and communicate information. They take a blank digital canvas and give you the tools to turn it into a business report or a school project. Then you have multimedia software. This is the creative side of the world. Think of Photoshop for editing photos, Premiere Pro for cutting videos, or even something like Spotify for listening to music. These applications are designed to handle complex data like pixels and audio waves and let you manipulate them. They turn your computer into a dark room, a recording studio, or a cinema. Next, you have communication software. This is what has fundamentally changed how we live. Apps like WhatsApp, Zoom, Slack, and Gmail. These aren't just tools, they're gateways. Their entire purpose is to move data from one person's device to another as fast as possible, often simulating a face-to-face conversation in real time. And finally, there's specialized or enterprise software. This is the stuff that most of us never see, but the world would stop turning without it. I'm talking about the software that runs airline reservation systems, the programs hospitals use to track patient records, or the massive databases that banks use to manage millions of transactions per second. This software isn't meant for a general audience. It's built for a very specific professional purpose. One of the most fascinating things about application software today is how it's evolving. We've moved from on-premise software where you buy a box with a CD-ROM and install it on your hard drive to SaaS or software as a service. When you use something like Google Docs or Canva, the application isn't actually living on your computer. It's living on a powerful server in a data center somewhere. Your web browser is essentially just a window that lets you interact with that software remotely. This means you can start a project on your laptop in Pakistan and finish it on a tablet in Canada without ever having to move a file because the application and the data are stored in the cloud. So, in short, application software is the bridge between the machine's power and human creativity. It takes the raw capabilities of the hardware and the stability of the system software and turns them into a tool that can help you write a book, design a building, or connect with a friend across the ocean. Does that cover the depth you need for your project, or do you want to dive into how an app actually communicates with the OS to get things done?
Okay, my next question is, what is application? What is programming?
Let's dive into this because this is where the real magic happens. Programming is essentially the act of writing the musical score we talked about earlier. If software is the finished product, programming is the process of actually creating it. At its core, programming is the art of taking a complex human goal and breaking it down into a series of tiny logical steps that a machine can understand. Think of it like writing a recipe for someone who has never cooked a meal in their life and takes everything literally. You can't just say, make a sandwich. The computer doesn't know what a sandwich is, where the bread is, or how to use a knife. You have to be incredibly precise. You have to say, walk 5 steps forward. Reach out your right hand, grip the loaf of bread, lift it 2 inches, place it on the counter. That level of extreme detail is exactly what programming is. Now, the challenge is that computers don't speak English, Urdu, or any other human language. They speak binary, those zeros and ones. But by hand would be a nightmare. It would take forever, and one single mistake would ruin the whole thing. That's why we have programming languages. Languages like Python, Java, or C++ act as a middle ground. They are designed to be readable by humans using words like if, while, print, or return. but they have a strict structure that can be translated into binary. When a programmer writes code in Python, they aren't talking directly to the computer. They're writing a set of high-level instructions. Then a special piece of system solves the bridge between human creativity and machine execution. It's the process of translating a what if into a how to. It turns a person with a laptop into an architect of digital worlds, allowing them to build everything from a simple calculator to a complex virtual universe. Does that paint a clear picture of the process, or do you want to know more about the different languages and why some are better for certain jobs?
So viewers, this is the session for Maya. Today we will meet you and in another Maya session. तब तक के लिए अल्लाह हाफिज, पाकिस्तान जिंदाबाद.